Hi everybody, this is a video about the properties of logarithms, and there are 5 properties that we are going to talk about. The first property of logarithms says that if you take the log base b of a product, then that will separate to be the sum of the logarithms of the two things in the product. It says that a log of a product is the sum of the logs. And what I'd like to do as we're going through these is to verify that these are in fact true. And the way that I'm going to verify it is, let's consider the following example, we know that 3 raised to the 4th power is equal to 81. And if I think about that as being in exponential form, then in logarithmic form, that would say that the log base 3 of 81 is equal to 4. So this is going to be kind of my key example. So we know that the log base 3 of 81 is equal to 4. And so now when it comes to this, this property, I am going to try to verify it. And the way that I'm going to verify it is that I will consider the log base 3 of 3 times 27. And if you check, 3 times 27 is equal to 81, so this should be equal to 4. And what I'm going to do is try to evaluate it using this property, because if this property is true, then it should be the log base 3 of 3 plus the log base 3 of 27. Now, how do I evaluate the log base 3 of 3? 3 raised to what power is equal to 3, which that would end up being 1. And then log base 3 of 27, 3 raised to what power is equal to 27? Well, 3 to the 3rd power is equal to 27. And so the right-hand side here would simplify to 1 plus 3, which is in fact equal to 4. So I know that it should have been 4. It turned out to be 4. So what I have done is verified that this property of logarithms is in fact true. And it's important to note that I verified that it's true here. I have not proved that it is true. Okay, so that's the first property of logarithms. The second property of logarithms is a similar idea. The first one was about a product. The second property of logarithms is about a quotient. So it says that if you have the log base b of x divided by y, then that will be equal to the log base b of x minus the log base b of y. So the first property said that a log of a product is the sum of the logarithms. The second property says that the log of a quotient is the difference of the logarithms. So we would like to verify this. And what I'm going to look at to verify it is the log base 3 of 243 divided by 3. And if you check, 243 divided by 3 is 81, so this is the log base 3 of 81, so this should be equal to 4. So if the property is true, it should be the log base 3 of 243 minus the log base 3 of 3. In that last one, we found out that the log base 3 of 3 is equal to 1. To evaluate the log base 3 of 243, I'm considering 3 raised to what power would be 243. And if you check, that turns out to be 5. So the right-hand side of this property ends up being 5 minus 1, which is exactly what we thought it would be, and that is 4. So we have verified that this property is true as well. That brings us to the third property. And the third property says that if I have a log base b of something raised to a power, so x raised to the r, then that will be equal to r times the log base b of x. Essentially, what it says is that if you've got a log raised to a power, then you can move that power in front of the logarithm. Okay, great. Let's verify this one. And I'd like to verify it by considering the log base 3 of 9 squared. 9 squared is 81, so I'm asking the exact same question. This should be equal to 4. So if this property is true, I'm going to be able to write this as 2 times the log base 3 of 9. Log base 3 of 9, well, let's see. 3 raised to what power is equal to 9? Looks like that would be 2. So the right-hand side of this is 2 times 2, and lo and behold, that also is equal to 4. So third property, log base b of x to the r is r times the log base b of x. Fourth property says that if I have a base b and I raise it to the log base b of x power, so that logarithm is an exponent there, and the bases are the same, then this would simplify to just be the argument of the logarithm. That one looks kind of confusing, so let's definitely make sure that we verify this one. And I'm going to verify it by considering 3 raised to the log base 3 of 81. So these 3's have got to be the same. And then it should be the case that this is equal to 81 because the argument there is 81, and that should end up being that value of x. So let's just look at this one piece at a time. We've already decided that the log base 3 of 81 is equal to 4, so this is going to be 3 raised to the 4th power, and sure enough, 3 raised to the 4th power is equal to 81. So this formula, or this property of logarithms, is verified there. Again, not proved, just verified. And then we get to the last property of logarithms that we will consider. The last property is actually called the change of base formula. And what it says is that if you have a log base b of x, then you can write it as the log base c of x divided by the log base c of b. And why we care about the change of base formula is that most calculators only have a log base 10 button and a log base e, or a natural log button. And so those are the only logarithms that we can do on a calculator, and if we needed to evaluate a log base 7, then this formula can be used to evaluate those kinds of logarithms. Again, let's verify this. And I'd like to verify it considering the log base 9 of 81. So I have changed my example from the previous verifications. Just to check, 9 raised to what power is equal to 81? Well, that would be the 2nd power, so the log base 9 of 81 is equal to 2. And I'm going to check this property by seeing if it is the log base 3 of 81 divided by the log base 3 of 9. And so just so that you can kind of piece these things together, my value of b is 9 and my value of c is 3. I'm changing the log base 9 into log base 3, and I've got that x is equal to 81. All right, well, let's see. The log base 3 of 81, we have been seeing that a bunch in this video. That is 4. The log base 3 of 9, let's see, 3 raised to what power is equal to 9? That would be to the 2nd power. So this would be 4 divided by 2, which is in fact 2. So those are the 5 properties of logarithms. Again, let me just kind of scroll up here. So the first property says that the log of a product is the sum of the logarithms. Second property says that the log of a quotient is the difference of the logarithms. The third property says that a log of something raised to a power is the power times that logarithm. The fourth property says that if you have a base that is raised to a logarithm with the same base, then that would simplify to the argument of the logarithm. And the fifth property is the change of base formula. The log base b of x is equal to the log base c of x divided by the log base c of b.